On a clear, dark night, if you look up, you might spot a faint, fuzzy patch in the sky, barely visible to the naked eye, yet holding secrets beyond imagination. That's Andromeda, our closest major galactic neighbor, quietly shining across the vastness of space, a silent companion to our own galaxy. With just your eyes, you're glimpsing an entire galaxy, billions of stars, planets, and mysteries, spanning over 220,000 light-years, a true sibling to our Milky Way. The urge to explore, to cross that immense dark ocean between galaxies, is deeply human. We've always wondered what lies beyond the next horizon, and Andromeda calls to that curiosity. But the dream of visiting Andromeda is one we're almost certainly destined never to realize. Not just in our lifetimes, but perhaps ever, given the limits of physics as we know them. The gap between our ambitions and the reality of the universe is wider than the void we wish to cross. Even our fastest spacecraft would take millions of years to get there. The barriers aren't just technological, they're woven into the very fabric of space, time, and physics. The speed of light, cosmic distances, and the laws of nature themselves stand in our way. Yet, understanding why Andromeda is forever out of reach is a lesson in humility and awe. It reminds us of our place in the universe and the limits that define our existence. As we explore the mind-boggling distances and the laws of physics that stand in our way, we'll discover just how precious our place in the cosmos truly is, a tiny oasis in a vast, mysterious expanse. The story of why we can't go is, in itself, a cosmic adventure, one that reveals the wonder, the challenge, and the beauty of our universe. To understand why a trip to Andromeda is impossible, we must first grasp the staggering distance that separates us from our galactic neighbor. The numbers involved are so immense, they almost defy comprehension. The Andromeda Galaxy lies an astonishing 2.5 million light-years away from Earth, a number so large it's difficult to visualize. A light-year is the distance light travels in a single year, about 9.5 trillion kilometers, or nearly 6 trillion miles. Light, the fastest thing in the universe, races across this distance in just 12 months. But Andromeda isn't just 1 light-year away, or even 100. It's 2.5 million times that distance. So far that even our most advanced spacecraft seem to stand still by comparison. Imagine counting every grain of sand on every beach on Earth. Even then, you'd still fall short of the number of kilometers separating us from Andromeda. The scale is truly mind-boggling. Consider Voyager 1, humanity's most distant spacecraft. After more than 40 years, it has only just left the solar system, a tiny step compared to the gulf between galaxies. Light from the sun, traveling at 300,000 kilometers per second, takes just 8 minutes to reach Earth, and about 5 hours to reach distant Pluto at the edge of our solar system. But to cross the void to Andromeda, even a beam of light must travel for 2.5 million years, longer than the entire history of human civilization. When the light we see from Andromeda tonight first began its journey, modern humans didn't even exist. Our ancestors were still evolving, unaware of the vast universe beyond their world. This immense distance is the first and most fundamental reason our dream of visiting Andromeda remains just that, a dream, at least for now. Crossing this cosmic chasm is nothing like traversing our solar system. It's a leap so vast, it stretches the limits of our imagination and technology. The universe is not built on a human scale, and the distance to Andromeda is a humbling reminder of our place in the cosmos. Before we even consider technology or engineering, the sheer distance itself stands as an almost insurmountable wall, one that challenges our curiosity and our dreams of exploration. What if we just built a really fast ship? The Parker Solar Probe, our fastest spacecraft, reaches about 700,000 kilometers per hour. At that speed, a trip to Andromeda would take 4 trillion years, 300 times the age of the universe. Even if we made a ship 100 times faster, the journey would still take tens of billions of years. Long before arrival, the sun would die, Earth would be gone, and the ship itself would be dust. Our technology, impressive as it is like a snail trying to cross an ocean. The problem isn't just slow rockets, it's the unimaginable scale of the universe. Using current technology, a trip to Andromeda is not just impractical, it's physically impossible on any human timescale. The universe dwarfs our most ambitious engineering. We are masters of our world, but the cosmos operates on a scale we can barely comprehend. The journey would outlast the stars themselves. Suppose we could build a ship that travels at 10% the speed of light, 30,000 kilometers per second. Even then, the journey to Andromeda would take 25 million years. The world would be unrecognizable by the time the ship arrived. Why not just go faster? Einstein's theory of relativity says nothing with mass can reach the speed of light. As you approach light speed, your mass increases, and it takes infinite energy to go faster. The speed of light is the universe's ultimate speed limit. Even if we could travel at light speed, the trip would still take 2.5 million years from Earth's perspective. The universe has set a firm boundary on how fast we can move through it. No matter how clever our engineering, the cosmos has rules we cannot break. Science fiction offers shortcuts, warp drives and wormholes. Warp drives like the Alcubierre drive propose bending space-time itself, but require exotic matter with negative mass, something we've never observed. The energy needed would exceed that of all the stars in our galaxy. Wormholes. Theoretical tunnels through space-time could connect distant points instantly. But most models suggest they'd collapse instantly, and keeping one open would again require vast amounts of exotic matter. These ideas are fascinating, but remain firmly in the realm of speculative physics. For now, warp drives and wormholes are beloved science fiction, not engineering projects. The universe's laws are stubborn, and shortcuts remain out of reach. Our best ideas for beating the distance are still just dreams. Reality for now is a harsh critic of our cosmic ambitions. Even if we could solve the problems of time and distance, the journey itself would be perilous. Intergalactic space is a near-perfect vacuum, filled with deadly radiation and high-energy cosmic rays. Without Earth's protection, radiation would slice through a ship and its crew, making survival nearly impossible. Shielding would add immense mass, making acceleration even harder. At high speeds, even a grain of dust becomes a lethal projectile. The ship would need robust shields just to survive the void. Sustaining a crew for decades or centuries would require a self-sufficient, perfectly stable ecosystem, far beyond our current capabilities. The technical, biological, and social challenges are as daunting as the distance itself. While we may never travel to Andromeda, there's a twist. Andromeda is coming to us. This distant neighbor, visible as a faint smudge in the night sky, is actually on a slow-motion collision course with our own Milky Way galaxy. In about 4 to 5 billion years, the Milky Way and Andromeda will collide, merging into a new galaxy. This cosmic event will unfold over millions of years, creating spectacular displays of swirling stars and gas as the two galaxies dance around each other before finally settling into a new, larger galaxy, sometimes called Milkomeda. Despite the drama, stars will rarely collide. Instead, the galaxies will pass through each other, reshaping their stars' orbits. The vast distances between stars mean that even as galaxies merge, individual stars are unlikely to crash into one another. Instead, their gravitational forces will create new patterns and possibly trigger the birth of new stars. By then, our sun will be dying, and Earth will be uninhabitable. The sun will have expanded into a red giant, scorching the Earth and making life as we know it impossible. Our planet's story will have ended long before the galaxies finish their cosmic embrace. This cosmic timetable gives us perspective. The universe operates on scales far beyond human experience. The events that shape galaxies unfold over billions of years, reminding us how brief our own existence is in comparison to the cosmos. When you look at Andromeda, you're seeing it as it was 2.5 million years ago. The light reaching your eyes tonight began its journey before the first humans walked the Earth, carrying with it a message from the ancient universe. The light began its journey before modern humans existed. It traveled across the vast emptiness of space, passing countless stars and cosmic wonders, to finally arrive here, connecting us to a time long before our own history began. If someone in Andromeda looked back, they'd see Earth as it was in the distant past. They would witness a planet untouched by cities or technology, perhaps even before the rise of humanity itself. A living snapshot of our ancient world. This is the closest we get to time travel. A humbling, beautiful connection across the cosmos. Every time we gaze at the stars, we are looking back in time, glimpsing the universe as it once was, and sharing a silent bond with distant worlds. We may be stuck in our corner of the universe, but our minds and eyes can still journey across it. Through science, imagination, and wonder, we can explore the mysteries of space and time, reaching far beyond our physical limits. The story of Andromeda is a reminder of our place in the grand cosmic narrative. It shows us that we are part of something vast and ancient, a universe filled with stories waiting to be discovered. And that's more than enough to inspire wonder, curiosity, and a sense of belonging to the universe itself.